All right, let's talk about substitution method for linear quadratic systems. So I have equals x squared plus 3x minus 5 and y equals x plus 3. The top equation's quadratic because it has the squared. The bottom is linear because it's in slope-intercept form. So since we have y isolated, we know we can use substitution method by substituting in x squared plus 3x minus 5 in for y in the other equation. So we're going to get x squared plus 3x minus 5 equal to x plus 3. So when you have a system and the variables y are both isolated, you can use substitution method by basically setting the two equations equal to each other. Now we know from solving quadratics that in order to solve, it must equal 0. So I need to get rid of this x and I need to get rid of this 3 by subtracting x from both sides and subtracting 3 from both sides. That's going to give me x squared plus 2x minus 8 equals 0. A quick way to solve this would just be to use the quadratic formula. So here a is 1, b is 2, c is negative 8. Let's go ahead and plug that into the quadratic formula to get negative b plus or minus the square root of b squared minus 4 times a times c over 2a, which we can type into our calculator, negative 2. I'm going to do the plus first, so plus the square root of 2 squared minus 4 times 1 times negative 8 over 2 times 1. So one of my answers that I get is that the x value is 2. And then the second answer I get when I change this to minus is x equals negative 4. And then we're not quite done though, because we know when we solve systems, we really need to have a coordinate pair, a point that they cross at. So I'm going to go back up to my original system and I'm going to pick one of my equations to find y with. I can use either equation, but to me, this second equation is the easier one to use. So I'm going to use the equation y equals x plus 3, but I'm going to plug in the 2 that I just found to get y equals 2 plus 3, which gives me y is 5. So the first point of intersection is 2, 5, the first solution. So that's one solution. I'm going to use the same equation, but now I'm going to use negative 4 as my x value to get that y is negative 1. So my other point of intersection is negative 4, negative 1, which if we were to switch over to the graphing calculator and we were to graph our original system, y equals x squared plus 3x minus 5 and y equals x plus 3, you'll notice that the 2 points of intersection of the line and the parabola are 2, 5 and negative 4, negative 1, which we were able to get algebraically using the substitution method.